Right, so the number under the square root's the same, and the index is the same. They're both square roots. So this one is yes. This one was no. What about number 3? Because the radicand, the number under, are not the same. What about the third one? Why aren't they? Right. So in order for them to be alike, the radicand and the index must be the same. I'll give you a minute to write it down. I have the square root of 63. So the first thing I'm going to do is I'm going to break down 63 into a factor tree, just like we did yesterday. So two numbers that multiply for 63. 9 times 7. And then 9 breaks down into 3 times 3. And bring my 7 down. And now when I go to rewrite it, I cannot just like throw this 5 away. I have to bring it down. So I'm just going to bring down this 5. And now I'm just going to rewrite like we did yesterday. 3 squared, there's a pair of them. Square root of 7. Keep bringing this 5 down. The little square and the root cancel. They undo each other. So this would be 15 square root 7. That would be its most simplified form. Okay, would you try the second example? And then check and see if your neighbor ends up with the same answer and you all have a little discussion about. Get 10 square root 2. Alright, let me break it down. Let me do it here. So here's what we would do. In case you missed it. So I would bring this 2 down. And I'm going to come over here and I'm going to break 50. So 10 times 5, for instance. 2 times 5. There's my doubles. So we said yesterday that the exponent of a 2 and the square would undo each other. You could also think about the 5 squared is 25. What's the square root of 25? 5. Yeah. So we get 10 square root 2. Now, again, if you were to put this in your calculator to check your answer, you could put 2 square root of times the square root of 50 in your calculator and get like whatever that decimal is. And then you could put in 10 times the square root of 2. You should get the same decimal. So you should be able to check yourself pretty easily that way. If you don't get the same decimal, then you've made a mistake. And you can go back and find it. Okay? All right, let's look and see how we could add and subtract. In order to add and subtract square roots, you have to have like terms. Okay? So look at the very first example. I'll give you a minute to write it down. 2 times the square root of 3 plus 5 times the square root of 3. Now what you can kind of think of, and try to relate this back to something that you already know. If you had 2x plus 5x, what would that equal? 7. It's just 7x, no squares. We're not multiplying, okay? We're just combining like terms. Just combine like terms. It works very similar in the square roots or the radicals. You want to check to see, do you have the same index? We do. We have the same radicand, the 3, so it's possible to add these together. So what we really want to do is look at the 2 and the 5, and we would get 7 square roots of 3. Okay? Just combining like terms. Look at the second example. It looks a little different. Write it down, and then we'll do it. Okay? Each one individually. So I'm going to take this 2, I'm going to bring it down, and I'm going to break 12 down into maybe 6 and 2. So we could rewrite it as 2 squared times the square root of 3. The square and the square root undo each other. So this is really 4 square root of 3 for that first term. Then we're going to do the one in the middle. I'm going to bring down this minus 3. It's just going to keep getting brought down until the end. We're going to break 27 down. I'll come down here and do it. 27, 2 numbers that give me 27. 9 times 3. Circle up my double, so this would be like saying 3 squared under the root times the square root of 3. I'm going to bring down this one. The square and the root cancel. So this is really like 9 square root of 3. Oh, look. See how these became the same now? All right, let's do the last one. You do the last one, please. You got when you broke 48 down. I got 2 pairs of 2s. And then I had a 3 left over. Okay, now here's the number one mistake is that students will, and even I'll forget to bring this 2 that I started with down. So just kind of be cautious. Did I have any numbers to keep with? All right, so the square and the root cancel. The square and the root cancel. They undo each other. So let me write it all out. So 2 times 2 times 2 is 8. Square root 3. Now look, all of our radicands are the same. And all the indexes are square roots. So these are like terms now.
I got 4.
You got 4 what? For this last one? Did you forget to bring down this 2 from the original problem? That's what happened, yep. All right, so we can add and subtract. So now we have 4 minus 9 plus 8. 3 times the square root of 3. Again, if we want to check this in our calculators to see if we did it correctly, you could actually put 2 times the square root of 12 minus 3 times the square root of 27 plus 2 times the square root of 48. You hit equals and you'll get a decimal. And then you put in 3 times the square root of 3, you should get the same decimal. This is equivalent. Okay? All right, so your homework is the worksheet that you picked up off the stand today.